Now let us see the pointers with arrays. Let us see with a one-dimensional array now. So for example, an array is declared like int x of 5 like this. Let us take the array is initialized with specific values 1, 2, 3, 4, 5 like this. This one-dimensional array stores the values 1, 2, 3, 4, 5 in this array. And in the memory locations, these values will be stored 1, 2, 3, 4, 5 with the addresses. Let us assume 2000, 2002, 2004, 2006, 2008. These are the memory locations of corresponding array element values one by one. Let us take like that. Now let us initialize one pointer. So the declaration of a pointer, let us take like that. This pointer should store the address of an array instead of address of a ordinary or a simple variable. This pointer should store the address of a particular array. How it stores the array means just by taking pointer variable is equal to name of the array. We know that an array name indicates the base address of the array. Here it is indicating 2000 and the first element is the x of 0, second x of 1, third x of 2, fourth x of 3 and last one x of 4. These are the 5 elements in this one-dimensional array with the corresponding addresses like this. So this is the address of x of 0, address of x of 1, this is the address of x of 2, address of x of 3 and address of x of 4. The corresponding addresses will be like this. So pointer is equal to, here we are assigning the name of the array. That means the base address of the array we are assigning to this ordinary pointer variable. That is nothing but we are assigning one ordinary variable x of 0 address in this pointer variable. So we can assign like this in this C language. So that is the pointer with arrays concept for one-dimensional arrays. Pointer is equal to directly the base address of the array we can assign. So that is nothing but here the pointer variable stores the base address. Here we are taking 2000. It is some more address is there for this pointer in the memory, but this pointer value is 2000. This 2000 indicates the address of this array which is declared here. Now how to access different values by using this pointer, let us see. So by using this element names we can access the values, and we are storing this element array base address in the pointer. Now by using pointer, how to access all these individual elements? Let us see with the help of one example program. Before entering into that program, we have to know one point, that if this pointer is used with increment operator, what happens? Or if this pointer is added with an integer value, that is 1 or 2 or 3, then what happens? Let us recall these points. So if a pointer is increment by using an increment operator with the pointer, what happens means the pointer address should be incremented to the next data type value. That means here pointer stores 2000. If it is used with an increment operator, after increment this pointer stores 2002, not 2001. We should recall this point in the pointers. So a pointer after using increment operator, it will go to the next integer data type element or next same kind of data type element. Otherwise, if the pointer is added with an integer value 1 or 2 or 3, then what happens means, here also the same thing, pointer is added with 1. So pointer value is 2000 here. So if this 2000 is added with 1, it should go to the next integer again. Not 2001, it should indicate 2002 after adding with 1. If it is pointer value is adding with 3, let us take. Now this pointer is initially at 2000, indicating 2000 value. Pointer is added with 3, then what happens means, this pointer after adding with 3 means, it indicates the third element, third integer element. That means it is first 2000. After adding with 1, it indicates 2002. After adding with 2, it indicates 2004. After adding with 3, it indicates 2006. That means if PTR plus 3, when PTR is indicating 2000, it should indicate 2006, not 2003. That point we have to remember. That is nothing but, for this address PTR is equal to X means, here the PTR value is 2000, or it is having address of X of 0 element. Now if PTR plus 1, if we do like that, then it is nothing but 2002 we are saying. That indicates address of X of 1. That means X means the base address of the single dimensional array. So here this address is assigning to the pointer variable. This pointer after increment with 1, it indicates the address of the next data element in the single dimensional array. So first data element we are assigning, after that we are adding with 1, nothing but this pointer indicates the next data element. So this is equivalent to assigning the address of the second data element of the array. Otherwise, if we take PTR plus 2, that is nothing but we are saying 2004. So after this step, if we do like this, PTR plus 2, that indicates 2004. Here 2004 is nothing but address of X of 2. Address of X of 2 is nothing but after X of 1, the next element is X of 2. Like that we are having, after this step, if you take PTR plus 3, that is equivalent to 2006, that is nothing but address of X of 3, next element to the X of 2, and the next element, if you from pointer, if you write PTR plus 4, it is indicating 2008, which is nothing but the address of X of 4, which is nothing but the next element of this one. Like that, when adding with one value for the pointer value, it should indicate the next integer data type element, not the direct next value of the byte, right? So after recalling these points, let us see one example problem to access the array elements by using pointers. We are declaring one dimensional array first, and then we are declaring one pointer variable, and let us take some ordinary simple variable I initialized with 0 like this. Now first let us take a statement printf element at address. After this statement, let us take a while loop while I less than 5. Here we are taking a printf statement X of, we need element value and its address value. So first let us take X of %d is equal to %d at particular address with address specification format %u, and after this printf statement, let us increase the I value and pointer value. Now let us see this code segment. After execution, what happens? Let us see step by step. So in the declaration part, we are taking one single dimensional array and one pointer variable and one ordinary variable I with initialized with 0. Now first, after this execution of this statement, we will have a statement on the screen, element at address in the first line. Next, while condition is there. In this while, condition is I less than 5. So I is assigned 0 here initially. So I less than 5 means condition true. So condition true means this code segment will be executed. So printf statement x of %d. Here %d, this specification format. So here the code segment is first one element value, second one element value, and third one address of that particular element. So directly we can take pointer ptr like that. So this %d indicates the value of I, this %d indicates the value at the pointer. That means this pointer stores one particular address. The value at that address is nothing but this %d, which is nothing but the element value. And next %u. %u means address of that particular element or pointer value. This is ptr. Now in this printf statement, what happens means, let us see. So in the first, after declaration statement, let us assume that the values will be stored like 1, 2, 3, 4, 5, and let us take the addresses are like 1000, 1002, 1004, 1006, 1008 are the consecutive memory locations for these array elements. Now in this x of %d is here I value initially it is 0. So this indicates x of 0. So first here the printing matter is x of 0 is equal to, next %d, this %d is here value at that pointer. So here after initializing, after declaring this pointer, a pointer will be allotted some value. Let us take address of this pointer some 3000. After that, this pointer should be having some initially some address. So let us take the initialization of this pointer here itself with array name. That means we are taking the pointer variable value as directly base address of this array. That means here x of d is equal to %d. So value at this pointer. So pointer is having initially the base address of the array, which is we are taking 1000. So let us take 1000 here. So this is called value at that pointer means pointer is having address 1000. Value at that pointer means this 1000 is a address of other variable memory location. So this value 1 will be accessed. So this value is pointer is equivalent to pointer is nothing but here ptr, we are assigning that x base address of this array or base address of the first element. This is the x of 0. So address of this one. So this is value at address operator. This is address of operator. So both are, this is equivalent to x of 0 value. So this statement is nothing but the array element value. So we can observe like this. So initially this pointer is having 1000 address. At 1000 address, after the initialization of this array, we are having 1 value. So that x of 0 will be 1 printed. After that 8. Here %u indicates ptr. Here in this statement ptr is equal to base address of x. So initially address 1000 will be printed. After that in the next statement I will be incremented by 1 and pointer also incremented by 1. When the ordinary variable I value is incremented by 1, this I value now it is from 0 to after increment it will become 1, and this pointer value After incrementing, what happens means initially this is having 1000, after incrementing it should indicate with 1002, the next data element value. So now again the loop begins again. In the second iteration, this condition with I value 1 we have to verify. So I less than 5, so 1 less than 5, condition again true, the loop segment part will be executed. So again the next iteration what happens means, again here I value is incremented. That means this percentage value will be incremented by 1. Next, this percentage indicates value at this pointer address. So this pointer is now having address 1002. So value at that pointer. That means this is nothing but the next data type element value, that is x of 1 value will be there. So x of 1 means it indicates with 2. So x of 1 is equal to 2, 8. Now the address will be pointer value. The pointer value is now 1002. So we will having the display like 1002 like that. In the next iteration, I value is increased with 2. This pointer value will be increased with 1004. So those will be correspondingly printing. X of 2 is equal to 3 at 1004. After incrementing, I value will become 3. Again this 1004 value will be incremented to 1006. So the display will be x of 3 is equal to 4 at 1006. Next, in the final iteration value, I value is increased to 4 and this pointer value is incremented with 1008. So the last element, so the display will be x of 4 is equal to 5 at 1008. Now after this, again I value will be increased by 1. Now I value will be 5 and pointer value will be 1010 after incrementing of the final iteration. Now with I value 5, the while condition 5 less than 5, it condition fails. That means this say code segment will be skipped by the compiler. So that finally after execution of this code segment, we have the display on screen like this. So here we are displaying these element values by using this pointer variable, not directly by accessing the array element value. That is the benefit with the pointers. So we can access the array element values by using the pointer variables by using indirection operator. So we are not directly accessing these values by the array element names. We are using one pointer, and by using indirection operator, we are indirectly accessing these array element values by using these pointers. That is the pointers with one-dimensional array.